Welcome students. Here in this video we are going to discuss polar form of a complex number. Previously the complex number z x plus iy we were discussing was in the Cartesian form. So now let us discuss polar form of a complex number. Let us see. Let z is equal to x plus iy be represented by a point P having coordinate xy in the complex plane. We have already discussed in the previous video that this plane consisting of x-axis x dash ox and y-axis y o y dash perpendicular to each other is known as complex plane, or this plane is called Argand plane. Correct. So we have already discussed that every complex number, let's say z is equal to x plus iy, can be represented with the help of any point P with coordinates x, y. Correct. This is Cartesian form. So suppose this distance OP is r and this angle XOP is theta. Let distance OP is r. This is always positive value, and angle XOP is theta. Then any point is this point P with coordinate r theta. This is known as polar form. Then P r theta is called polar form of this complex number. P r theta are called polar coordinates. Here r theta are called polar coordinates of the complex number z. Complex number z. Okay. So the same point P having coordinates r, theta, where r is distance OP and theta is angle XOP is called theta. So now in place of x we can write corresponding value. If you draw a perpendicular here, suppose PM is perpendicular on x-axis, then this distance OM is equal to r cos theta and PM is r sin theta. Here in this figure OM is x, now this is equal to r cos theta, and this distance PM, which is y in Cartesian form, is equal to r sin theta. Okay, so therefore the complex number z, which is having coordinates xy, now can be written as coordinates OM is r cos theta and PM is r sin theta. Therefore z, which we have written earlier x plus iy, x is r cos theta, x is equal to r cos theta, so this is r cos theta plus I r sin theta, and r is common, so r cos theta plus I sin theta. Z is equal to r into cos theta plus I sin theta. This is polar form. This is polar form of the complex number, correct. Here r is called modulus of z. Here r is modulus of z and theta is called argument of z, written as arg of argument of z. So in this way we can write any complex number in polar form. This is polar form of the complex number. Z is equal to r into cos theta plus I sin theta. This is polar form of any complex number. Z is equal to x plus iy. Here origin O is called pole. So that's why this is known as polar form. Correct? So that's all about the polar form of a complex number. Now in the next video we will see how to convert a complex number from Cartesian form to polar form and polar form to Cartesian form. So keep watching these videos and share these videos with your friends also. Wish you all the best.